Hello everyone. I welcome you all to this another video of the series of Leetcode daily problem solving. So if you are new to the channel, you can subscribe my channel. I upload uh, video solutions, in-depth video solutions of Leetcode daily challenge problems, and you can check it out. I have also added the playlist in the description box. You can also follow me, send me a connection request on my LinkedIn profile as well as my Facebook profile. Okay, let's see today's question. So this is running sum of 1D array. So we have been given an array nums, and we define the running sum as if running sum of I as it is the sum of nums of 0 till nums of I, right? So for example, this is the given array. So the array has four elements: 1, 2, 3, and 4, right? This is the index 0, index 1, index 2, index 3. So then running sum of z of, let's say I want to calculate running sum of 2. This is basically what sum of nums 0 plus nums 1. No need to write sum. Nums 0 plus nums 1 plus nums 2, right? What is the running sum of 1? It is nums of 0 plus nums of 1, right? What is the running sum of 0? It is just nums of 0, right? Up till I. So this is the running sum. What is the running sum of 3? It is nums 1 plus nums 2 plus nums 3. I forgot to mention nums 0. Nums 0. Starting from nums 0, then up till I. Nums 0 plus nums 2, and so on. So we can say that the initial strategy is that what we can do for each I will calculate the sum. Let's say I'm at index 4th, then I'll calculate sum from nums of 0 till nums of 4, right? And for I equals to 3, what I would have done, I would have calculated sum of nums of 0 till nums of 3, right? So you can see there, if I go with this approach, what I'm doing for some to calculate some running sum of some ith index, I will take order of I time, right? So for the first index, I will take one time. Then for the second index, I'll take two units of time. Then for the third index, I'll take 3 units of time, and so on. For the nth index, I'll take n units of time, right? And this sums up to n into n plus 1 by 2, which is order of n square. So by this approach, we will take n square time, right? And if we see the given limit of the n, it is 1000, right? 1000. So with the given limit 10 to the power 3, if the algorithm is n square, then this will lead up to 10 to the power 6 computation. This will be accepted, no issue. But we can still do something better here. You can see that what I'm doing for fourth index, I am calculating sum from 0th index up till 4th index. And for the index 3, I'm calculating sum from 0th index to 3rd index. So there is some overlap between these two, because if I'm calculating running sum of a larger I, it also calculates sum for the smaller I. To calculate sum for the running sum of 4th index, I am calculating first of all running sum up to 3 index, you can say, because nums 0 plus nums 2 nums 3, and then to that I will be adding nums of 4. So once this I have obtained, I will be calculating running sum of index 5. It will be sum of nums of 0 up till nums of 5, right? I have already calculated sum from nums 0 to nums of 5. I do not need to recalculate this thing. I can store this thing. And then to that, I can add nums of 5. So in this way, I will be calculating sum of some ith index in order of one time, right? How order of one time? Let's see this. Okay, let's see how order of runtime. So I was given, let's say my array is 1 2 3 4 5, right? Initially I'll calculate running sum for index 0, it is 1, right? And I have stored what is the sum before this index, so that was 1. Then to calculate running sum of this index, first index, I need running sum up to 0th index, it was 1. And to that one I'll add this number, this is 2, right? So 1 plus 2, this is 3. I'll store here 3. And what is the sum up till index, running sum up till index 1? If this is 3. So to calculate running sum for the index 2, I need running sum. I need the total sum up to index 1 that was stored as a running sum of 1, right? So what I can do, I can easily add to the running sum of 1, 3 plus what is the element here. So it is 3 plus 3, 6, right? You can see this. And so on. So what I'm doing, I'm just doing one computation to calculate running sum of this index. I'm doing one computation to calculate running sum of this index. So I'm taking order one amount of time for each index, right? For if there are n indices, I'll take n number of computations only. The time complexity is reduced to order of n, which is very fast, right? I hope you understood. If you do not understood, if you have any doubt, you can mention this in the comment. The problem is very simple. Today's problem is there's nothing big to understand. So let's code this in Java. Okay, so we need to return the running sum array. So I would say that I'll initially store the size of this nums, right? And I'll create an array where I'll be storing the running sum, right? Okay. So I'm creating an extra space of order n, and even we don't need this because what we are doing, I can directly rewrite. I can use this array only, the given array, because essentially what I'm doing when I'm iterating on this nums, when I have done work till this index, I do not require the previous. What was the previous elements? I can overwrite those elements. I just need the original element in the right side, right? If the array was 1 2 3 4, right? Initially the running sum of this index is 1, I can override here, right? Now to calculate running sum of this index, I just need original element that was placed at this index, and since I have not changed this element, so this is the original element, I can add the previous running sum to this, so this is 3, right? Now to calculate running sum of this index, I need just an original element which was there, and I have not changed this element, so I can easily add running sum, previous running sum to this index, so this will be 6, right? And then similarly I will add previous running sum to this element, so this will be 10. So I can simply return this way, I can do the computation in the same array, right? So I do not require this. And what I will be doing, or let's say, because the index 0th has the running sum equal to that element because nothing is before that. So I can start with the first index. So I should be less than, I'll go up to the end of that array. And what I am doing, I'm basically doing this nums of I is plus equals to what? Nums of I minus 1, right? And this will be the running sum, and I can simply return the nums array as it is. So, okay, so I think that is it, and it should work. Let's see. The sample test cases. Okay, should be y equals to 1. So yeah, it is getting accepted, and nothing very fancy or big thing in this. So the solution should be accepted. Let's submit this. No need to test for the larger inputs and some awkward inputs. Okay, so the solution have been accepted, right? And it is one of the fastest solutions. So I hope you understand. You understood the concept, and how we do all these optimization, how we have saved the space, how first of all how did we optimize the time from x square to n, and then how did we save the space as well here, right? And we'll be continuing later. We'll see the harder questions in great detail. There's nothing more to explain here. If you have any doubts, you can mention these in comments. You can check out my playlist of the previous problems as well, and you can subscribe to the channel because I upload videos daily for the daily challenges. And let I'll I hope to see you in the next video. Thanks for watching the video.